when the silver prototype, designated 7822 and equipped with a massive radar dome, once again sliced through the sky. A question quickly spread through military observer circles. Why did the radar on this new generation strategic early warning aircraft abandon the seemingly advanced fixed three-panel array of the KJ-3000, instead making the radar spin again? Is this a technical step backward, or does it conceal a disruptive trump card? Judging by the test flight footage recently circulating online, the development pace of this second prototype, dubbed the KJ-3000, is clearly accelerating. Following the debut of the first demonstrator, 7821, the addition of 7822 typically signals that the project has moved beyond the single aircraft technical validation phase into a more advanced stage, involving parallel test flights of multiple aircraft to comprehensively evaluate system stability and combat effectiveness. Based on the historical development patterns of high-end equipment like large early warning aircraft, if subsequent test flights proceed smoothly, the widely anticipated timeline of achieving initial operational capability around 2027 is indeed a highly significant milestone. The most significant change in this second prototype lies within its massive radar dome. Unlike the KJ-3000, which employs a three-panel fixed electronic scanning array radar, the KJ-3000 features a larger dual-panel rotating active phased array radar. At first glance, switching from a fixed to a rotating array might seem like a compromise in terms of refresh rate, but in reality, it represents a design trade-off aimed at achieving optimal detection performance. For a fixed three-panel array, each panel can only utilize one-third of the radome's surface area, severely limiting the size of the active elements. The KJ-3000's dual-panel array, however, effectively integrates two massive back-to-back antennas into a single disc, increasing the area of a single active element by at least 40% compared to previous designs. In radar technology, aperture directly determines power and aperture product. The larger the active surface, the more GaN transceiver modules can be installed, leading to a corresponding increase in transmit power and receive sensitivity. Sacrificing a few tenths of a second in refresh rate to achieve a significant extension in detection range is a calculation that makes perfect sense in modern air combat. The confidence behind this design stems largely from a thorough overhaul of the carrier platform. Instead of continuing to use the imported Ilyushin Il-76 transport aircraft, the KJ-3000 is modified based on the domestically produced Y-20B large transport aircraft platform. This represents a fundamental shift. Looking back at the earlier KJ-2000, although its radar system was highly advanced at the time, the limited number of Il-76 platforms meant that only a small number of units were ultimately deployed nationwide, making it difficult to achieve large-scale deployment or sustain long-term strategic watch duties. The subsequent KJ-500, while equally technologically advanced, was inherently limited by its medium-sized transport aircraft foundation, which meant it could never fully undertake strategic-level airborne command missions due to constraints in range, endurance, and internal space. Now, based on a modified Y-20B and equipped with the more powerful domestically produced WS-20 turbofan engine, the KJ-3000 not only boasts significantly increased range and payload capacity but, most crucially, provides an extremely ample power supply for the high-power radars and data processing equipment on board the early warning aircraft. There is another easily overlooked detail in the recently released images. An aerial refueling probe is installed at the nose of the aircraft. This indicates that the KJ-3000 is capable of aerial refueling. With the support of an accompanying tanker, its endurance can be extended from the standard 8 hours to over 10 or even 20 hours. This ability to maintain a prolonged presence in airspace far from home represents a qualitative leap forward for strategic early warning and airborne command operations. Of course, the core of an early warning aircraft ultimately lies in its radar. It is widely believed that the KJ-3000's radar system likely employs a dual-band or multi-band fusion design. Some analysts suggest that within that massive radar dome, one radar may operate in the S-band, responsible for high-precision detection and identification, with a detection range for large aerial targets expected to exceed 900 kilometers or even approach 1,000 kilometers. Another radar unit may operate in the UHF band, which offers a natural advantage for detecting stealth fighters such as the F-22 and F-35. Based on comprehensive information, the KJ-3000's detection range for stealth targets is estimated to reach approximately 400 kilometers. If this figure is accurate, its anti-stealth capabilities would fundamentally alter the current landscape of aerial combat. This means that while the enemy's stealth fighter is still attempting to penetrate the KJ-3000, can already lock onto its trajectory from a great distance and guide long-range air-to-air missiles to intercept it. This is not merely a technical improvement, but a redefinition of battlefield situational awareness. Beyond its ability to see far and clearly, the KJ-3000's greatest value lies in its capacity as an airborne command hub. The spacious fuselage provided by the Y-20B allows it to accommodate more control consoles, operators, and more complex data links and communication equipment. It is no longer merely a flying radar station, but rather a command center in the sky. Through advanced data link systems, it can connect in real time with stealth fighters such as the J-20 and J-35, as well as drones, satellites, and even surface ships and ground-based air defense units. It can track hundreds of targets simultaneously, automatically assign tasks based on threat levels, directly guide friendly aircraft to intercept threats, or provide critical relay guidance data for ultra-long-range missiles such as the PL-17, thereby fully realizing the missile's range potential. It is this systematic combat capability that poses the greatest challenge to adversaries in modern air warfare. Turning our gaze to the global landscape, the current development outlook for large early warning aircraft is actually not optimistic. Russia's A-100 early warning aircraft project has been progressing slowly, while the US E-7 Wedgetail project, intended to replace the E-3, faces various challenges related to budget constraints and the discontinuation of the Boeing 737 platform. Looking around, there are indeed very few nations still fully committed to developing brand new large-scale strategic early warning aircraft. Against this international backdrop, once the KJ-3000 is successfully finalized and enters mass production, it is highly likely to become one of the world's most advanced and capable large-scale early warning platforms for the next decade or so. In the future, it will form a high-low mix system with the currently operational KJ-500 and KJ-2000. The KJ-3000 will be responsible for forward deployment, strategic early warning, and airborne command, while models such as the KJ-500 will handle coordination in deep rear areas and tactical missions. Together, they will build an airborne early warning network with extremely broad coverage and a clearly defined hierarchy. If test flights continue to progress, by around 2027, when this strategic early warning aircraft, based on a fully indigenous platform, equipped with an oversized dual-band radar, and possessing aerial, refueling capabilities and powerful command functions, begins to appear in large numbers in the airspace of the first island chain and beyond, it will represent not only a massive leap forward for China's aviation industry, but also a potential rewriting of the rules of air combat. The journey from relying on imported platforms to now possessing a fully independent and controllable strategic early warning system speaks volumes in itself. As parallel test flights of multiple prototypes deepen, the answer to the question of why the radar is spinning again is becoming increasingly clear. This is not a simple repetition, but a strategic move to overtake competitors by taking a shortcut toward the future.